Welcome to another video, guys. We are going to take a look at how to subnet for beginners. We are going to cover a number of sections in the presentation today, and firstly, what is a subnet? We are going to delve deep into what is the purpose of a subnet and answer the age-old question of how to subnet. We are then going to move on to the basics of IP addressing, and next moving on to the different types of classes within those IP addresses, and finally just reviewing a CCNA practice question. What is a subnet? Well, a subnet divides a very large network into exactly what it says, a smaller sub-portions of that network. Subnetting is a very effective method to manage your network sizes and the hosts that reside within those IP address ranges. And as it says there on the slide, this prevents large numbers of IP addresses from going unused. Moving on to the basics of IP addresses, they are 32-bit binary numbers which can be converted to decimal. An example of an IP address, which I think we are familiar with, is 192.168.1.1, which you'll see probably on your home router or any other places that are very small. These IP addresses are separated into what we call 4 octets, and each octet is a group of 8 bits, which is where you get your 32-bit binary number from. In the table below, I have identified the binary sequence which an octet is made up from. Going from the powers of 2, we have 2 to the power of 0, all the way to 2 to the power of 7. Now that I've demonstrated what the table is used for, how do we exactly convert from decimal to binary? As it says on the slide, I'm going to use 192 as the example for converting that decimal number into binary. Firstly, we want to subtract 192 from 128, which gives us 64. We are subtracting by 128 because that is our highest power of 2, being 2 to the 7. And remember, in an octet, we have 8 host bits. Secondly, now that we know we are subtracting by 128, we can place a 1 inside the block, which goes in the table below. You'll see a 1 under 128. This gives us a remainder of 64, and this fits perfectly inside of our next block, which gives us a remainder of 0. And what you want to do is repeat that until you reach 0. And you should end up with a table below, which is our octet representing the number 192. Continuing from our previous slide, we have an IP address of 192.168.100.1, and we are going to show how we can convert that to binary. We have our first 2 octets, which are 192.168, and they are represented in the table below, following the formula from the previous slide. And moving on to the last 2 octets, which are 100.1, again shown in the table below, and our decimal dot is represented by a red line. With our 4 octets now complete, we can bind all of the numbers together to give us the binary of the converted decimal 192.168.100.1. I would recommend you guys stop at this point and just review what we've done and come up with some examples of your own, following the formula that I shown you in the previous slide. On to our next topic of IP address classes. Well, the first question is, why do they matter? When IP networks were first designed, we have different classes and they range from A to E, but for now we'll just keep on the topic of A, B, and C. As it says on the slide, we have Class A, which is very large networks, ranging to Class C, which is our smaller size networks. And the first octet displayed there shows what category they will fall in. So in this presentation, we'll be dealing with Class C. This is really important to subnetting, as we can only subnet our host bits, which are represented by the blue H's. To summarize this slide, I've created just a few graphics. On the right hand side, you can see the 4 octets, which shows octet 1 is the network portion. So if you were dealing with a Class A network, you have 24 host bits you can use for subnetting. Onto class B, it's a 50-50 split, and finally onto class C, where, as I said before, we only have the last octet, which is 8 host bits. Tying the previous slides together, how can we calculate the number of hosts we need within a network, or indeed a subnetwork? The amount of hosts you can have is very important, as you don't want to end up with a subnet that's really small and you run out of IP addresses, or one that's too large and you have a lot of wastage. The formula for this is 2 to the power of h, where h is your host bits minus 2. Why do we subtract by 2? Well, that's because we have 2 reserved addresses, the very first address being the network address, and the very last address being the broadcast address. Now, using everything you've learned within this presentation, I am going to present a practice question from the CCNA. So you are required to subnet the following IP address, which is 192.168.100.0, into 4 equal sized networks. The question asks us to use the second network range and detail the following. What is the subnet mask that's going to be used, the network address, the first usable address, the last usable address, and the broadcast address. And I know what you guys are thinking, you really don't want to be this guy, so what we're going to do is I will walk you through each step and break each part down. What we need to ask ourselves is, what do we know already? So the IP address was 192.168.100.0. We know that 192 is a class C address, so we only have 8 bits that we can manipulate for subnetting. The question also asked us to divide the network into 4 equal size subnetworks using the formula 2 to the power of 8, and we're using 8 because we have 8 bits that we can control for subnetting, which leaves us with 256, and it wants us to divide those equally by 4. So we go for 256 divided by 4, which gives us 64. And that can be represented in the table below, where 64 is our magic number. So we put a 1 into 64 and the ones preceding it, so into 128 as well. A lot of people talk about the magic number in subnetting, and for me that's just the block size. So if this question wanted you to divide the network into 8 equally sized networks, you would do 2 to the power of 8, which would give you 256, divide it by 8, which would be 32, and then we would need to add a 1 into 32, into 64, and 128, very similar to what we had before. This will give us a final subnet mask of 255.255.255.192, and can be represented by a /26, and that is because it's 26 ones. We know that 255 is 8 ones, so we have 3 there, which is 24, and then we have 2 additional ones, which is in 128 and 64, so we have 26 concurrent ones. And guys, that's the hardest bit, so we're doing really well. What do we now know? We have 4 equally sized subnetworks, and each of those subnetworks have 64 available IP addresses. And if we were to draw them out, we will have our first range, which is from .0 all the way to 63. And remember, it always starts at 0. And then if we move on 64 to 127, which then ends in our last range at .255. And wrapping up the practice question, let's just revisit what the question is. You are required to subnet the following IP address into 4 equal sized networks. Use the second network range and detail the following. From what it asked us before, we have all of the answers. What is the subnet mask? Well, we know that's a /26. If we go back to that previous slide, we know that we have our magic number of 64, and that represents an extra 2 subnet mask bits, which is resulting in 26 ones, which gives us a subnet mask of 255, 255, 192.168.255.192. Our network address is going to start at .64 because that, remember, that's the very first address of our second range. Our first available IP address is going to be one up from our network address, which is .65. Our last usable address is going to be one lower than the broadcast, and the broadcast being 127. Thank you guys for watching, and if you've really enjoyed these walkthroughs and the practice questions, please leave a comment, like, and don't forget to subscribe. Thanks for watching.